Right. GM guys, sorry for the slight delay. So I think we can start soon already. Thank you very much for coming here on a Saturday evening. You know, it's at 12 p.m. You know, usually you'll be spending time, I don't know, with doing something else, but still you decided to come here. So thank you very much for that. So BYOS is our very first episode of the Build Your Own Stuff series workshop. We're going to start with Ethereum dApps for today. So let me just go to the next slide. See, getting used to the screen. One moment. Yeah. So I'll start with some self-introduction about myself, so you just get a rough idea of who's actually the host for today, and like at least you know that I'm not just a random guy sharing random stuff. Okay. Yeah. It's a bit annoying. Okay. Okay. So here's some details about me. Oh, sorry about the socials that's down there. I think I forgot to delete that. But yeah, these are some details about me. I'm still a cybersecurity student at Asia Pacific University, year 2, Sem 1. I'm working part-time at Etherscan as a customer operations associate. I'm also the vice president of PR and external affairs of the Blockchain Club. At the same time, I'm a scholar of CopyDAO. Over the past few years, I've joined 15 hackathons and won about 10 awards. Now, despite me running this workshop, I want you guys to be aware that I'm still new to blockchain. I'm still learning. So the best I can do is GM, right? So just don't judge me too hard, okay? But yeah, so these are some details of what I'm doing. If you have any further questions about some of these companies I'm associated with, like Etherscan or even the CopyDAO, you can ask me more later. Okay, next. What is the agenda for today? I need to just share this. Okay. Hey, can you see the stream on YouTube? Check and see. Can. Okay. So this is the agenda for today. We're going to start off with some really basic Solidity syntax. So, you know, with every programming language, you start with some hello world, and then you'll be able to build your first app. You learn some primitive data types, variables, and also constants. And then you'll proceed with some Q&A, 15 minutes of Q&A, so you can just ask any questions. And then we have a lot of facilitators here who can help you. And then from 1 p.m. to 1:45 p.m., we will learn a bit more basics of Solidity like mapping, array, enums, structs, and some information about data locations. Again, we'll get into more detail about all this later on. And then we have rest time from 1:45 to 2 p.m. Then from 2 p.m. to 2:45 p.m., you'll learn like the really advanced part, but not too advanced part of Solidity, like functions, the different types of functions, what are some errors, what is function modifiers, and even what is events. And then we will sort of wrap up the basic sessions with another 15 minutes of Q&A, and then you will have 1.5 hours of project time. So it's not just enough to learn about all these stuffs, right? So you even have to apply all this knowledge and try to build something that you can actually test it out and just be sure that you can you really learn something at the end of the day. And then 4:30 p.m. to 5 p.m. we will do some sharing among each of us just to recap on what has been learned and what are some next steps. You know, after you learn all this, where can you apply? Maybe it could be for open source projects or hackathons or many more. Okay, next. Enough talk. Let's start building. So first thing I want you guys to do is head over to this website, soliditybyexample.org. I'm just going to share my screen. Just one moment. Okay. I present, share screen. Here. Okay. Can you see my screen, right? Okay, so I'm assuming everyone can see my screen. Just gonna. Oh, I can see all this chat. All right, so let's start with Hello World. Okay, I'm just gonna zoom in a bit. As you can see here, now you guys have 2 ways to go about this. Okay, before that, is everyone here or not? Anyone having issues coming here to this page? No one? All good? Okay. All right. So first thing here is, as you can see, okay, here there's Pragma. So Pragma actually, with Solidity in general, you need to specify the compiler version of Solidity. Now with each different compiler version, it determines how, like when you write the programming language, right, the smart contracts, how it gets compiled to bytecode. So for some of you who are somewhat familiar with programming, okay, who here is not familiar with programming? Please give me a raise of hands. Anyone? Okay, that's good. So you guys, you somewhat know that when you code something, then it has to be compiled to a bytecode so that it's executable by the machine, right? Is anyone like familiar with that? Anyone? Okay. All right. Anyways, so similarly, you have to specify pragma to ensure like what is the compiler version of Solidity. So this is what we do. The first thing, we have to specify the compiler version, and then you pretty much start off with a contract here. So contract here, you will start off with this keyword, then you will specify the contract name, and then this is like a local variable. Now what we're going to do is, now I wanted to actually try this on Remix. So why don't we just go ahead and try that? So you go here. I'm just gonna accept this. All right. So this is Remix. Now, in terms of how you build Solidity, right, or how you build smart contracts, you have few different options of doing it. You can do it using Remix. You can do it using Hardhat. You can do it using Foundry. Remix is good because it helps you to quickly prototype your smart contract. So maybe you're in a hackathon. You want to quickly build your decentralized application, but then you don't want to waste time writing tests or things like that. You want to quickly find out whether your smart contract is working or not. In that instance, you can use Remix. So I'll just go through very briefly what are some interfaces here on Remix. So obviously you have your main IDE here, the Integrated Developer Environment. And then at the side here, you can actually view what are the files here. Now, I think particularly in Remix, you don't have to worry much about how the file is structured. So you can just skip that. Then there's search function here. There's also the Solidity compiler. Now, Solidity compiler, you have to specify here. So in our case, since, okay, this compiler here, right, you actually have to cross-check it with what you define here. So this arrow here, right, the small arrow, like it means above 0.8.17. So that is the same compiler that you have to specify here at the left side. So you just specify that, and then you just compile a contract. It will compile successfully. And then if you try to run this script, right, so ideally it should just return this hello world kind of value. So if you compile and run script, now it will return an error saying that, there you go, you have not set a script to run it. So for this part, right, what I'll do is I'll just like copy this. Then if I try to search online, okay. Let me see here, okay. Right. So obviously Stack Overflow is my best buddy. So I just search here, and then you just copy this line. Then you go back over here, paste the same thing, save it. Now let's try running it again. Okay, file part does not exist. I'm just gonna delete that. Okay. Can launch. Oh, okay, wait. Better? Okay. All right. Let's try to compile and run the script again. Okay, fine. Ignore this for now because later on we're going to work with deploying it. So let's try to just go through some of the basic concepts. So we have already went through the hello world kind of thing. Let's go to the next section, which is first app. So here, now here's a simple contract that you can get to increment and decrement the count store in this contract. So as usual, it's the regular thing. You specify a compiler version. Oh, also I forgot to include one more thing. Here you actually have to mention your license identifier. Now there's a few types, MIT, there's unlicensed, there's a few different types. So this one really depends on you as a developer. How do you want to copyright your contract? Like, do you want people to be able to reproduce it, or like what are some factors that goes into that? We won't get into the detail of that, but what I want you guys to know is that this thing exists as a comment there. And then you start by defining the contract here. Then there's UINT public count. So UINT just means unsigned integer. Unsigned integer, again, I won't go into the details of it, but there's three different types. There's unsigned integer, there's string, there's signed integer, there's object, and there's a few more. So we will first declare an unsigned integer here called count, and this is publicly accessible. So there's a modifier there called public. And then you have a function to get the current count. So you define a function here, you have the function's name, and then there's public, there's view, then it will actually return. So return actually indicate what is the return value, which is an unsigned integer. Then you return the count here. If you notice, right, the syntax is a bit familiar to Java. and also C++. So it's like a bit of a combination of these two. So that's your get function. And then you have a function to increment the count by 1. So here's a function increment, then it will increment the local variable count here by 1, right? And then you also have a function to decrement the count by 1. So you guys get the rough idea here, right? Any questions so far? Any questions? All good? All good? All good? Anyone online? Any questions so far? I see 5 people online, so I'm assuming no. Okay, I'll move forward. And then we have the next, primitive data types. So primitive data types, there you go. Like what I mentioned earlier, you have Boolean. So there's Boolean, true, false, unsigned integer. Now unsigned integer 256 just means like what is the size of the unsigned integer. And then integer 256 is also the same thing. Address is a bit unique. Now this corresponds to, like, you know, when you have an Ethereum address, your public address, like when your MetaMask address, things like that kind of format, right? That is the data type that is involved in Solidity here. So let's take a look at how this contract works. So we start with a contract name. We define a Boolean variable this time. So just now we noticed it was an unsigned integer variable. This time we're defining a Boolean variable called BOO, and we are giving it an initial value of true. And then okay, so there's comments here. It's a good practice. When you're coding in Solidity, it's a good practice to just put some comments so people know what you're doing. So here it says that unsigned integer stands for unsigned integer, meaning non-negative integers. The different sizes are available. You have unsigned integer 8, which ranges from 0 to 2. Okay, so this one just means power of 8 to 1. So it's 0 to 2 power 8 to 1. So 2 power. I'm not sure how the actual representation of it is, but at least the comment here specifies a few things. So there's unsigned integer 8, unsigned integer 16, up to unsigned integer 256. So you sort of declare all this here, right? All these values here, and then negative numbers are allowed for integer types. So that is the difference between unsigned integer and integer. So unsigned integer, you can't allow non-negative integers, but integer types, integer variables, you can allow negative integers. So like unsigned integer, the same different ranges are available from integer 8 to integer 256, as mentioned here in the comments. And then what else? Okay, integer 8 public. Okay, you have all this regular stuff. So as you can see, there's actually a very clear difference. Like unsigned integer, you can't actually assign a negative here, and then like here you can actually have the negative values, this and this one. So minimum and maximum of integer. Now this is pretty interesting because so let's say you define a kind of a variable here, min integer, and you sort of say that, okay, this integer type, you want to set it as a minimum. Now this part you might have to do a bit more research on that, because even I am not too clear on this. So this minimum and maximum is something that I have not fully explored yet. So this is something definitely we can check out more in the coming hours. So next is address. So like what I mentioned earlier, if you notice, right, the format here is pretty similar to how your MetaMask is. So I'm not sure if you guys can. Okay, I'm just going to show my MetaMask real quick. So as you can see, this is like the format of the address, right? So it's a bit similar to how we sort of store the address here. Then in Solidity, the data type byte represents a sequence of bytes. So Solidity presents two types of byte types. So you have a fixed size byte arrays, and you have a dynamically sized byte arrays. So fixed size and dynamically sized. Let's take a look at what is the difference between these two. So the term bytes in Solidity represents a dynamic array of bytes. It's a shorthand for byte, right? So here you have bytes 1, A is equal to 0xb5. So this is in hex format. If you convert it to binary, you will actually get these values. The same goes for this one. And then, so that is essentially the bytes format. So now you're just learning the data types. But in the long run, you'll get to understand for what use cases you need to use what data types. You have a clearer picture on that. Right? For now, let's just go through what are the different data types. Then for default values, now unassigned variables have a default value. So let's say Boolean. You're defining a variable using Boolean. the default value for that Boolean variable is false. And then for an unsigned integer, the default value is 0. Not negative 0, not positive 0, just 0. And then for a signed integer, which is just integer without the u, the default value is also 0. And then for address, this is the default value, 0x with a long string of zeros. So that is pretty much like a really quick crash course on primitive data types. There's actually more than this, but we won't go into the full details at this time of the workshop. Then next, let's take a look at variables. See, okay, so I personally think this is quite important for you guys to take note of. So in Solidity, there is 3 types of variables. Now, how you define the variables is important because it actually affects the efficiency of your smart contract, the size of the smart contract. So if you're not careful on how you declare the variables and how you manage the state of the variables in your smart contract, it might affect like the sort of effectiveness of the smart contract. So let's figure out what that means. Now, for a local variable type in Solidity, right? It's declared inside a function. So you have a contract, and then you have a function. Inside a function, you're declaring a variable. So that variable is specific inside that one function. It can only be called within that one function. So this variable is specific to the function, but it's not stored on the blockchain. And then you have the state variable. The state variable is declared outside a function. So let's say you take a look at, so thank God there's a example code here. So there's contract here. Then these 2 variables is considered state variables. Then there's a function here. You're declaring this unsigned integer I, which is equivalent to 456. This is a local variable. And then these are some examples of global variables, right? So you have unsigned integer timestamp and an address sender. Now you might be wondering, like, hey, this timestamp and sender is also defined inside a function. Why is it a global variable and not a state variable? So it's a global variable because it's providing information about the blockchain itself. So here you're defining an unsigned integer timestamp, and it's equivalent to the block.timestamp. So I'll explain a bit about how, like, when you do transactions on the blockchain, how it gets included on the blockchain. So generally, when you perform a transaction, it's all stored inside a block, and that block would be actually mined and stored on the blockchain, right? So essentially, to identify the timestamp of which the transaction happened, you're essentially looking at the block.timestamp, which is here. So that's how you essentially get the timestamp of a certain transaction, or if you want to know like what the details of the block. So this is actually providing information about the blockchain itself. That is why it's considered a global variable. And then in this case, now message.sender, right? So imagine you're a user, you want to deploy a smart contract. Message.sender would correspond to your address because you're the contract deployer. That's what it means. So address to the caller. That is one example of message.sender. So local variable, state variable, and global variable. That's the basics of it. Let's see. Is there anything else I haven't covered? Oh, we still have constants. So constants. I'm just gonna go there real quick. So I think so far it's all good, right? All good? All good? Guys? All good? All good? Okay. So we went through primitive data types. We went through a simple hello world. We went through variables. Now constants. So constant just means that it's a variable which does not change in value. So as what is mentioned here, there are variables whose value cannot be modified. Their value is hard-coded. And one key thing here, right? Now, when we are talking about blockchain, we essentially want lower gas fees. Let's think of it like a bigger picture. You want your users, people who use your decentralized application, to have a good user experience. How do you do that? Faster transaction, lower gas fees, better scalability. One way you can reduce gas fees is by using constants. But then again, only in certain use cases you can define variables that are constants. So here we have a simple contract called constants, and in this contract you're defining a constant called my address. Now, maybe, right, okay, for this use case, so let's say you're running I want to give a really simple use case. Maybe you're a DeFi. Okay, no, not DeFi lah. Let's not go DeFi. Too far already. Maybe you just want to. Okay, you're running a smart contract to be able to track how many times your friend has sent you like waves. So let's say they come to your decentralized application, then they sort of click on the button like wave, and then they send to you like a transaction to wave to you. Now maybe, right, you want to store a constant address to keep track of the amount of waves. So you want, like, there's a contract where you want to keep track of the amount of waves. So there's an address for that contract. You don't want to keep on dynamically changing the address. So you define a constant for it. This is one way of saving gas costs. Now there might be more use cases that we might think of. So that's why later on when we do the project from 3 to 4:30 p.m., we can explore more of these constants. And then you have another variable down here, unsigned integer, public constant. Then you define it with 1, 2, 3. This one, right? Again, it really depends on like what is the variable that you want to declare. How do you want to declare it? Do you want to make it into a constant, or do you want to make it into a dynamically changing variable? So this is like the crash course on the starting part of Solidity. So we have covered like how to start the syntax wise of Solidity. We have covered like how to declare a contract. We have covered some primitive data types. We have covered some constants. We have covered some variables. We have covered how to declare it. So I think so far, okay, we still have a few minutes left. So just gonna try to. I want you guys to actually go to Remix. I want you all to try to explore this. So we're gonna explore this together. So is everyone on Remix right now? Are you all on Remix already? This IDE? We're just gonna go through it one by one and try to figure out how to interact with this. Because Remix is really interesting. And once you get a hang of it, it will actually help like speed up your development process on Solidity. For right now, I'm gonna try to figure out how to run the script. So just gonna do this real quick. So we have a simple hello world contract. We're gonna try to run this. So the error that we get here is this. So I'm just gonna go here. I'm gonna search Remix. So what I usually do is when I'm unsure about something, because what I do is I'll just go to either this documentation, or sometimes ChatGPT helps. Just saying. So if you can go to ChatGPT, you just search the problem, you can get a solution for it. Let's take a few. Let's see if anyone else has faced this problem or not. Okay. Okay. So customer sweet. Anyone manage to run the script? Yeah, run. See your side? Wait, let me try. People online, can you all follow easily? If there's any questions you have, just drop it in the chat here. I'll try to answer it if I can. So some people are actually facing problems with running the script because it's actually asking to specify the custom div run script. So we try to figure that part out. So the solution right now is to actually add this comment here. But then I think we have to actually also add this file part. So what I tried to do was rename it to byos.sol. Then let's see if this works or not. Now it compiles successfully, but it's still giving me the error that I've not set a script to run. So let's try to figure out why. Okay, so it does get deployed successfully. If I try to go scroll down, okay. Oh, okay. Wait. So, okay, yeah, it works now. So what you guys have to do is, okay. You have to deploy the features. Okay, so you already specify using this one, when you deploy the project, basically means that it's deployed to the blockchain, right? And you scroll down, you click on this deploy projects. So, all right, I'm going to demo one more time, so you guys can just follow my screen, all right? What we're going to do right now is, so you already have the contract, right? Then just go over to this this left side here. There is actually, so what we went through just now was that there is four like buttons here, right? So this one actually tells you how to compile. So basically you set all your settings here. So since we already specified the compiler version which is above 0.8.17, that's what we set here in the compiler. We don't touch the other parts first. We'll get to that later. So just make sure it compiles successfully. You should see a green check mark. Don't worry about this warning here first. You go over to this deploy and run. For now, we just choose Remix VM. Later on, we will use our MetaMask wallet and try. So we try this first. Then you should click on deploy. After you click on deploy, there should be a data here that says deployed contracts. So I think initially you would see it like this. You just expand this. You click on the grid button. You should get a return value of string hello world. Is everyone able to get that? I think we can try more examples since we have like a bit more time. Okay. I just have another system. So, the green button, right, is one way of how you can interact with the contract. So, as we go ahead, there will be more contents that will be available. So, you have more ways of interacting with the contract. So, we will explore this. Okay, now that you already can retrieve the value of string, let's try to declare a variable and then we try to manipulate a variable. So, let's go back to the solidity by example here. Okay. So, where is it? Okay, here. We go back to variables, and then we go to primitive data types. I think this first app. Yeah. Why don't I just go to the first app? So you guys can just copy this entire thing. What you do? There's a button here at the top right. Just click on that. Head over to your Remix IDE. You go here. Just copy everything up to pragma, and you paste it. Yeah, of course you get this warning. So just a general precaution when you're trying to do smart contract development, and let's say you come across a code snippet on GitHub, and then you decide to implement that smart contract functionality in your own decentralized application. Make sure to audit that smart contract, because sometimes smart contracts that are not audited might be harmful in a sense that it might actually, let's say, cost more gas for your users, or it might maybe contain malicious code, you don't know, right? So what I try to do is, again, this is just a side tips, right? It might work, it might not work, but you can actually try pasting the code snippet on ChatGPT and just ask it if it's any vulnerabilities or not. Maybe let's try that. So I'm just gonna copy this code, so at least you guys can know roughly how we can go about asking ChatGPT this stuff. I never thought I'd be teaching ChatGPT for a while here, but yeah, sure, let's do it. Okay, so we go here, we just paste the entire code snippet, and then we just ask, is there any vulnerabilities with this code? And let's see what it answers me. Okay, are you able to see the screen, or do you want me to zoom in? Can see, yeah? Okay. See, there is a few vulnerabilities here which we will tackle later. I'm just going to stand because I feel more comfortable standing. Here we go. Let me see the screen there. Okay, so there's actually three areas highlighted here. No access control, integer overflow/underflow, and then read and transient. So let's briefly look into what are some of these vulnerabilities. No access control. So it means that anyone can call a function. This is actually a very bad vulnerability, because it means that when your contract there is no proper access control, you're leaving, like, we know access control in general. Whenever you implement any software, you need to have a control mechanism so that essentially it's a proper layer of security. Not everyone is able to call the smart contract, right? Maybe there are certain functions that you only want it to be callable by certain important people in the organization. So that's access control. And then integer overflow/underflow. So let's say we define a maximum value. So do you guys remember initially when we defined a variable unsigned integer? We gave it unsigned integer 256. So 256 is like the maximum size, right? But let's say you're calling the increment variable, and then let's say that the variable is already, the value of the variable unsigned integer 256 is already the maximum value, and then you increment it again, we call that an integer overflow. Now let's say underflow is pretty much the same thing. Now let's say you're already at low value 0, and then you decrement it, you go to -1. That will result in a problem in your code. Pre-entry attack, I think eventually it's not a concern. I don't know if it's specified here, so let's just ignore that. Then, okay, those are some of the vulnerabilities. When we try to implement our contracts later, so it's normal for you guys to make mistakes. So we will try to just see how we can avoid some of these mistakes when we try to put smart contracts. Going back to this IDE, so we've already pasted this code here. Let's try to compile it again. Okay, there's an issue here. It's saying there's multiple SPDX license identifiers. So there's one here and there's one here. We just have to delete this. Then we compile again. It should work now. So compile. Okay, compile successfully. Let's try to deploy this contract again. So we deploy it. And then, okay, so there's a counter function here, right? We click here. Yeah, so as you guys can see, there are a few buttons that you can play around here. Let's try to get the current value of that local variable. So currently 0, right? Let's try to increment it by 1. And then we try to get again. It's 1 now. Let's try to decrement it and get. Now what happens if we decrement it again and get it? Okay, there's actually an issue here. Try to. Okay. Just gonna bring this up a bit. You see, transaction mine, but execution fail. So we know what is the error here. Can anyone tell me what error is it? Why is it showing an error? We just went through it with ChatGPT just now. Anyone? What? Yeah, integer. Actually, it's integer underflow lah. Underflow. Yeah. Right. Yeah. You get price later. 15 you get from me. Okay. Now how about count? What does count do? Let's try to like increment, keep on incrementing, and try to count. Oh, so I think there's a difference between count and get. So if you notice, right, count here is actually for you to know what is the current value of the variable. But what if so just now we went through public. What if I put this as private? Then if I try to deploy it again, if I deploy it again, by right, the variable count should not be shown here. Means you're not able to actually get the value. But let's check and see. So let's try to deploy this, and then we go down here. Oh no, so sorry about that. MacBook problems. Okay, surprisingly it's still here. What if I try to same? Okay, wait. In private. Okay, let's try something. I want to try something. I want to copy this. I want to go to ChatGPT. Okay. How do I ensure that the value of count stays private? Just curious what ChatGPT will say. So, okay. So one thing I don't like about ChatGPT, sometimes it's too wordy. Okay. Let's try to see what this code does. So you're declaring count as private, and then you're getting the count internal view. So okay, there's internal view and then there's external view, I'm assuming. So if I go back here, this is public view. Okay, let's try something. Let's copy this. Go here. I'm just gonna close this. Bring this down. Screw this up. Does it compile? Okay, it compiles. Let's try to deploy again. So each time you guys have changes in your smart contract, just deploy it again, and you're able to see the updated functions here. Okay, so now you see there's no functions here. Why? Because most of these functions, right, you declare it as internal. Now, what if we try to maybe the get count, we try to put it as public. Then we try to we save this first. Then we deploy again. I hope I'm not going over time. It's 5:45. Okay. See? So you guys can see a difference now. When you define a function as like as public or internal view. So these are some of the differences. Okay. Let's take a look at some of the examples. So we already went through how to declare a variable, how to manipulate with a variable. Now, how about like other data types? How do we want to manipulate it, right? This is something we can definitely check as we go. So let's see. Okay, I'm actually quite curious what block timestamp are written. So I'm going to try to copy this code. I'm going to go to the Ethereum IDE, paste the same thing here. Um, then, okay. So you might be curious, right? Like, why is timestamp stored as a U integer? Now, let me tell you one thing. So before I explain about the data type, I'll just show what does the value of this timestamp look like. So I'm just gonna create a new function called function get timestamp. Um, so this one will just return timestamp. I save this. What's the timestamp? Yeah, stuff happens. So I'm just gonna try to. Okay. Vaccine deploys. Okay. Eh, bro, it's MacBook. It isn't written. Okay. So now what I'm trying to do is try to get the value of the timestamp. So I think I missed a variable, if a modifier called public view here. If I try to compile this again, still give me error. Never mind. I try to deploy again. Try to fix the errors later on. Uh, okay, yeah, finally got a value of timestamp. So you see this value here, right? Okay, you might be wondering what value is this. This is called an epoch timestamp, EPOCH. So we're going to try to copy this. Now this one, right, is actually corresponding to this block.timestamp. Now if I copy this and if I go online, I search epoch converter, right? EPOCH converter. If I go here, it's actually a Unix timestamp lah. So there's actually a converter that you can just convert this online. You paste the timestamp here, you convert it, you basically get Saturday, February 25, which is actually the current time lah. Close to current time. I think now this one's following GMT. Yeah, ours is GMT plus 8. If you notice, right, so I think it's the same concept. When you deploy a contract or when you're interacting with a contract, you might want to know like at what time the transaction occurred, right? So you might go to like Etherscan. You might go Etherscan. Now let's say I click on any random transaction. Maybe I go to blockchain, I click on transaction, and I click on this transaction, the most recent one. You see this timestamp, this data here. How do you assume they get the data? They actually get the timestamp first, they decode the data, and then they store it here. That is how people usually get the details of when a transaction occurred. That is what block.timestamp is for. Okay. Okay, I think, sorry, it's 12:51, I just noticed. Let's take a 10 minutes break and yeah, we'll continue at 1:15 lah, 1:15, yeah. Do you guys have any questions for now? Just gonna walk around and, hold on, this, okay. Let me put, listen. I'll put this on the slideshow first. Okay. Come, which code? The last one are the timestamps. Hey, Babu, this one. Never mind lah, I just show the screen je. A bit annoying lah, this screen. Never mind. Okay. So big. Okay. Alright. Public view. Okay. Actually, right, I noticed just now when I didn't put a view word, it actually didn't appear here. So public is important lah. But I think we put like internal view. Won't show one, I think. Won't show. Yeah. Just how I use. Wait, I try something. Yeah. No. So Okay, okay.
Huh? Q&A session, your break time, 15 minutes hour.
Actually, until 1:05 lah.
Now,
Now is yeah. Okay, before this is
oh, 1 5 Yeah, go toilet.
go lah. 1:05 I start lah. Yeah. I think I can remove this. So I'm only sharing the screen now. So maybe I can remove the slides. Good. I don't know how it
Oh,
works.
you don't want to.
So I'll probably just like go here.
Oh, you. So, wait. Say again. What do you want to do?
Because like I'm already sharing that screen, right?
Okay.
So I was thinking because I'm already like interacting with that screen,
Okay.
so why not the one just correspond to the stream lah? Because before this is like two different screens, right?
Okay. So now you. Wait.
So I'll just remove this one lah. So you.
Let's mute out first.
Okay. Okay, okay. We are back now. Okay, I'm sorry. I'm sorry for that. Okay, guys, is everyone with me? Give me some, give me some LFG in the chat. If you're with me, I see 6 people online. Okay, right. Okay. Yeah, sure. Hao Xiang, you have a question to ask? Please go ahead. Let's leave the non-relevant workshop questions towards the end of the workshop, Hao Xiang. So for now, let's proceed towards the workshop itself. Okay. Now we're going to do some more basic stuff. So just now, just to recap, we went through a simple Hello World contract. We created our first sort of simple app to increment and decrement a local variable called store. We went through some primitive data types like Boolean, unsigned integer, address type, and then we went through some what more, like variables, constants, how to manipulate your function. Maybe there are certain functions you don't want it to be callable by certain people. Sorry, you don't want it to be callable at all, right? So you declare it as an internal view. If you want it to be callable, then maybe public view. And then maybe what type of data you want it to return. We went through all this. So now let's take a deeper look into some more basic stuffs. And let's start with mappings. So we're going to do the same thing. We're going to go over to not rest time. we're going to go over to the solidity by example. So just go over to the face page here. We're not going to go through the rest for now. So just go right over to the mapping. Okay. Now, some of you might be familiar with arrays, but mapping and arrays are two completely different things. We will get to that in a short while. So let's first take a look at what mappings are. So maps are created with the syntax mapping, what is the key type, and what is the value type. There might be certain instances where for a certain key type, so let's say your key type is string, you want to map it to a unsigned integer. That is possible with a mapping, right? So the key type can be any built-in value type, bytes, string, or any contract. Value type can be any type, including another mapping or an array. So I'm pretty sure you guys are familiar with nested dictionary, nested arrays even. That is also possible with mapping. You can do like nested mapping. So one thing to note here is that mappings are not iterable. So let's take a look at this sample contract. We have a contract mapping, and in this contract, we are mapping an address data type to an unsigned integer data type, and we are declaring it as public, and the name of this variable is called myMap. And then, after this, we are declaring a function called get, and get takes in an address data type, and it will return an unsigned integer. And one thing to note here is that now the nature of mapping is that you have a key and you have a value. So it is natural that mapping always returns a value. If the value was never set, it will return the default value, right? So that is of course the theory part. We will get to the implementation part in a short while. Then we have a function set. For a function set, you're taking in an address data type, and you're also taking in an unsigned integer. So you want to be able to update the value at this particular address using this function. If you notice, right, up here, we declared a variable called myMap, which is a mapping. So I won't say variable, I'll try to make it a bit more clear. I'll say mapping. We will declare a mapping called myMap. We are calling this mapping here with this key value. And for this key value, we want to assign it this value. For this key, we want to assign it this value. And then we have function remove. For function remove, we are taking in an address data type, and we are using the keyword delete here. We will access this myMap, and we will delete the particular address located at this myMap. Then we have another contract. So I just mentioned about nested mapping, right? So nested mapping is like mapping from address to another mapping. So the syntax here is the same. You're mapping an address to another mapping, and in that other mapping, you're mapping an integer to a Boolean variable, and we're calling this nested. So it's the same that goes on here. Now let's try to copy this code into Remix and debug it together. So I'm going to copy this code. I'm going to go to Remix. I'm pasting it here. I'm compiling it. Okay, there's error. What is the error? Is that there are multiple SPDX license identifiers. So I'm just going to delete this one. Compile again. Should compile successfully. Everyone has already copied the code so far? Okay, I'm assuming yes. Right. Okay, I am going to deploy this contract again. Now there's one more thing I want to highlight here. Initially, right? Okay, let me just zoom in a bit. A moment. Oh shit. Okay. Now just now when we were doing smart contracts, right? We sort of like declare one contract inside one file, right? But it's also possible to have multiple contracts defined in one file. So let's say, notice, right, in one file here there is two contracts. One is mapping, another one called nested mapping. So if you want to deploy this, right, one thing you have to do is after you compile your code, you actually can select which one you want to deploy. So this is a bit of extra stuff. So let's say you want to deploy mapping. You've already deployed mapping. Then now you want to deploy nested mapping. You've also already deployed nested mapping. Then you scroll down here. I'm just gonna. So if you want, right, there might be like so many deployed contracts here. You can just remove it from the list. So it's easier for you to view what is the current contracts you're working on. So just remove it from the list. Remove all this. I don't need all this. Yeah. So now we have mapping and we have nested mapping. Okay. So right now I want to be able to I want to actually set an address inside. Oops, sorry about that. Okay. So now full screen. Okay. I want to set an address. So what I do is, okay, you all can try this one thing. Go to your MetaMask. So go to your MetaMask. You go to my MetaMask. I'm going to copy the address that doesn't have any int inside. Wait. Yeah. Right. I want to copy this address. I go to the function here. I paste that address, and I just give it a random value of 68. Okay, and then I set. Then I try to get. Okay. Now you've already set a value inside the mapping, right? And you want to know what is the value for your address. So what you do, you copy your address, you go to get here, you copy, you paste that address inside, you get it, you should get a value of 68. So yeah, I think is everyone able to follow through? Yeah, just gonna wait for a while. Now that is a basic example of how you're able to so you gave it two parameters, right? Now this function, all these functions are under the contract mapping. If I expand this contract mapping, this function here set, you're actually using this function here. And because if you notice, right, you're actually passing in two variables, your address and then an unsigned integer value. What if, now just now, who can tell me the difference between unsigned integer and integer? I don't want from Rehan, I want from someone else. Anyone? Unsigned integer and signed integer. Sorry? Which one can accept negative? Which one cannot accept negative? Okay, good. Good one. You've been focusing in class. All right. Okay. So, what if we try to give the set function a negative value, like negative 68? If we try to set it, you see it errored. value is out of bounds, negative 68. So, so now you roughly know, what's the difference between unsigned and signed. At least it's being shown here. So yeah, that is the get function. That is the set function. How about the remove function? So now you already set your address and an integer inside that mapping. You want to remove your address from the mapping. You just have to paste your address inside here. Then you remove it. And then if you try to like get again, right, you would get 0. That just means that your address is not inside the mapping anymore already. So this my map, right? My map actually, again, it's a variable. This my map is what you declared here. What if I declared my map as internal? Well, I don't think internal view works. I don't think it's a compiler. Let me just try and see first. Okay. I think even if I put it as internal, let me check first whether it can give me the value or not. So if I try to deploy again, okay, if I set this one, okay, that's weird. I need to remove this negative first. I set it, I get it. Can I get it here? Okay, I can also. Yeah, I might need to check again later. How are we able to, let's say, declare a variable as internal? Probably. You can probably check it out later. Okay, that was mapping. How about nested mapping? So nested mapping, we go to nested mapping down here. So again, I'm just going to remove all these unnecessary functions because I'm not going to be using it after this. So now nested mapping, right? Based on what we declare in the functions here. Okay. So the difference between nested mapping and mapping, I think we've already went through just now. But then now, right, in terms of how you declare the function, you now have an additional variable that you're including, which is a Boolean value here. So what we're going to try is, we try to set the value, right? So we give it an address, we give it a value of 68 again, then we say true. Then we try to set the variable. And then let's say we want to get the variable, right? We give it an address, we say 68, it should give me true. Yeah. So it's giving me true. So basically, right, how it works is that this function get here, you go here, you have an address and you have an unsigned integer. It will then return the nested mapping. It will access the value at address, and from the value accessed at address, it will access the value at 68. Now, what if you give your address another value, like 69, for example, right? So you go here to, you go to set. I think you can go to set, and then you say 69, and maybe you say false. Then you set. Then you try to get the value. Okay, so just now you try 68, right? 68 give true. How about 69? You give false. Now how about 70? 70 doesn't exist in the mapping. So by right, it should give like 0 or maybe like a default value. Okay. Oh no, it didn't. It gave me an error thing. Wait. Let's see. Okay. Forget. Okay, so I think I know what's going on here. In here, right, now because 70 doesn't exist, it gives a default value of false, right? It doesn't actually give 0 because you're not, again, you're returning where is it? You're returning a nested value here, right? And then you want to access the Boolean value. But Boolean value, like what we mentioned earlier, is that the default value is false. So it kind of makes sense for it to return false as a default value. So yeah, that is mapping. Okay, we have covered enough of mapping. Let's go to the next one. Okay, next one is array. So array. So as I mentioned just now, there is a difference between mapping and array, right? Let's take a look at it. So array can have a compile time, fixed size, or a dynamic size. I briefly mentioned this earlier. Now let's take a look at what this means. I'm going to straight copy this code and go straight to remix. I suggest you guys to do the same. I think it's easier to follow that way. Okay. So we're defining a contract called array. And wait, I'm just gonna zoom in a bit. Okay, we're defining a contract called array. And if you notice here, just like any other programming languages, there are multiple ways for you to define an array. You can, okay, UINT just here means that you're defining an array that only contains unsigned integer data type. It's also possible for you to do something like this, if I'm not mistaken. String. Maybe you want your array to only contain elements that are of string data type. So you define string. So what we do for now, for demo purposes, we just use unsigned integer. So this is one way. This is the second way. The second way, right, it's like you're already defining the array with some set values beforehand. And then this first one and second one, if I'm not mistaken, is how you define a dynamically sized array. Now, if you want to define a fixed size array, you're putting this keyword here, 10. So you're saying that in this array, I can only allow a maximum of 10 elements inside. So you put a number 10, and all elements will be initialized to 0. Now, let's say you have 10 elements inside, and you want to also declare those 10 elements. So you just have to do the same thing. Just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are your 10 variables. So I'm just going to copy this and paste it down here. So at least you guys know that there are two ways to define the array. So I go here. Okay, I'm going to delete this. And remember, in Solidity, the semicolon is very important. So don't forget the semicolons. It's like Java, you know, if not, a compiler will scream at you. So, right. So there you have it. Four ways of defining arrays of two different types. The first two is for dynamic size. The last two is for fixed size. Okay. Now the function. You have a function get that accepts an unsigned integer I. It will return an unsigned integer also. What it does is, now, can someone tell me what is the purpose of this function accepting I? Besides Weihan and Ilham. I want to hear from that side. Anyone? Can someone tell me, what does the I do? If you're familiar with computer science, it's extremely straightforward. So you have a function get here, it's accepting I, and you're returning something. But you have to know what the I is for. Index number, right on. Yeah. So it's returning the index number. And again, it has to be an unsigned integer. Obviously, you can't get an index that is negative. So this is one example of how you need to think before actually you define your data type. So let's say, what if you define integer I instead of unsigned integer? It means that you're allowing your index number to be negative. That shouldn't be the case. You should make sure that your index number is non-negative. So that is index number. That is one example of how you can return a specified element inside the array index. So Solidity can return the entire array, but this function should be avoided for arrays that can grow indefinitely in length. What this means is that, probably the case where it makes sense for you to return an entire array is maybe for fixed size arrays, not for dynamically sized. Because if your array is so big, remember when we talked about lowering gas fees, faster scalability, code efficiency, you have an indefinitely sized array, it will reduce your code efficiency. So you have to think about all these factors when you create your data types. Okay, so this is the function that will give you the entire array. Function get array, public view, returns UINT memory. We will get into why we specify memory in a bit. But right now, just take note of that. Okay. Then we have function push. It will add an element to the array. And then pop is the same thing. If you notice, right, there's actually a bit of similarities with Java. Pop, push, shift even. I think it's shift. Vincent, the shift, right? For the array. They're like, let's say like array.shift. Okay, we can explore later. Right. And then there's function get length. Get length, I think it's self-explanatory. You basically want to know how many elements are there in your array. Then you have function remove. As you can see, like just now, actually the answer for the question I asked that group, it's already here. You actually I just means index. It's short form. I just put I, faster that way. And then, so yeah, we have all these function examples. So function examples is like you're creating an array in memory. Only fixed sizes can be created. Now this is interesting. What if let's try something interesting and ask ChatGPT. What if we define function examples in maybe storage or call data? But then I realized we can't go into that yet because I haven't taught you all storage and call data yet, so it's fine. We go into this later. We will revisit this part later, but just take note of all these different ways of defining your arrays. Maybe let's try exploring it a bit. So I'm going to deploy this as usual. Yeah, I'm just going to remove all this stuff. Oops. Oh, I didn't. Forgot to compile this. Oops. Okay. So this one is my fixed size array 2. Then, okay. Then I go here. So examples is examples. Okay, what example does is it will define an example array in memory, right? What if we try to get array? It will give you an empty array. Get length should give you 0. Okay, let's try something. So you already declare. Wait, what is this? Okay. So in this instance, right, we are pushing this value 24 to, so based on what we defined in the contract here, you're pushing it to this array. ARR is actually this one up here. So maybe, right, let's try something different. Let's go to my fixed size array. So what we're going to do is we're going to try pushing like more than 10 elements inside the my fixed size array here. So you guys so this is the standard code, right? But I highly encourage you guys to just play around with it. Maybe if you think that there's a different way of like debugging the code, you want to explore something new, please by all means go ahead. That's the purpose of this workshop. We're all learning together. So yeah, I want to try something. I want to copy this array. Oops. All right. Copy this. I'm going to go to push here. Where's push? Okay. Then I just replace this. So what you're essentially doing is you're now pushing to a different array. And then now I want to get the value of this array. So you just have to replace this only. And then, right, what if now you want to get the entire contents of this fixed size array? You copy this, paste it here. That should do it for now. Then we try to compile again. Oops, error. Okay, what is the error now? Return argument type. Storage ref is not implicitly convertible to expected type. Okay, this is occurring at line 28. Here. Okay. Member push not found or not visible after argument dependent lookup in storage ref. Okay. Remember, push not found or not visible after argument dependent lookup in UI NT25610 storage ref. Interesting. Um, okay. Same thing. Okay, never mind. We will. So somehow, I think when we tried with a different array. Let's see. It's weird. It's very weird. So it works for a fixed size. Sorry, it works for a dynamically sized array up here. If we want to manipulate it. But mind, we'll try this again later on how to manipulate a a fixed size array. For now, that is the differences between the different array types here. Oh, there's also another example given here by Solidity by example. This is particularly on how you can remove array elements. Oh, this is pretty interesting. So like you're actually able to remove array elements by shifting elements from right to left. I'm just going to zoom in a bit. So what it means here is, okay, you're removing an array by shifting. So let's say you have initially declared an array with elements 1, 2, 3. Then you remove one. So you remove one, then it will become 1 and 3. That's interesting. Okay. Now let's see how that works. Just gonna try that. Compile. Array remove by shifting. Okay, you're defining an you're defining an array initially, then you're defining a function called remove. You get an index, require index. Yeah. So this is something new. There is a keyword called require. So sometimes, right, you want to do we call it a sanity check. So I'm just gonna use like very simple terms. Basically means like you want to make sure like your variable is like a valid variable. Now you know that initially we talked about like defining the proper data type for for your index, right? You want to make sure that it's that is a there is a non-negative number, right? So at the same time, maybe you want to also ensure that when a user gives the value of the index, it is always lesser than the length of the array. So in that instances, you use require. So you say require, then you open bracket, then you define your condition here. And if let's say the condition uh, fails, so let's say it's a true or false, right? If it's true, if it's true, then it will pass. But if it fails, if let's say index is more than array.length, it will give this message, index out of bounds. This is something we would use more often as we go. So just something to take note of. Then we are using a for loop here. So for unsigned integer I, which is the index, as long as it's lesser than array.length, then you increment it by 1. For this element inside, you actually okay. This is a bit difficult to explain theoretically. So let's try to use examples here. So if I go to function remove, right? Okay. What does the array return now? Okay, so from what I understand here, right, is that if you want to remove array elements by shifting elements from right to left, so this syntax here, right, is that you're removing an element that is located at index 1, which is like 2 here. Then your final product is actually 1, 3. We won't go too much into the details of how the entire process works. So let's say this is the first one, right? Then you have another example here. You want to remove an element at index 2. So you have 0, 1, 2. Then the end product is 1, 2, 4, 5, 6, which is here. So I guess it's the same for everything else here. Then you have remove array element by copying last element into the place to remove. Okay. I'm just going to see the comments on how they explain here. So deleting an element creates a gap in the array. One trick to keep the array compact is to move the last element into the place to delete. Okay. So you have a function remove. You're giving it an index number. You want to move the last element into the place to delete. So you're accessing an element at a particular array index. Now what you do is, the element at array index is equals to array, then array.length minus 1. So let's say you have an array of 2 elements. Then you call remove bracket 1. So array 1 equals array bracket 2 minus 1. So array at element at array 1 equals to array 1. So let's see how that works then. Array index this one. If I try to copy this, paste here. Oh. Okay. Okay. Wait, we go next one. Okay, actually, I can explain this, but it might be a bit confusing. So what is going on here is that okay, let's say you're declaring an array initially of 4 elements, 1, 2, 3, 4. Then you're calling the function remove 1. So you want to remove 1 from the array. Remove 1 is actually calling this up function here. So if you notice the up function here, right? So let's try to code it back. So basically, when you call the function, it will be like array 1 equals array 4 minus 1. Then basically, it's array 1 equals array 3. Yeah, array 3. So basically, right, what this means is that we know that for this particular function, we want to copy the function that we want to delete to the position that would be deleted, right? So let's say, we know that once we remove 1 from this array, we will be left with 2, 3, 4. That's 3 elements. And then if you want to access 2, 3, 4, is the index numbers are 0, 1, 2. 3 does not exist anymore, right? So after you do that, you're basically, okay, so just now we talked about require. Now you might be wondering, what is assert? Assert just means that, now there's actually a very, very good explanation I saw last time because I was initially confused. So I'm just going to do a simple search, require versus assert. We search, sorry. Want to zoom this for you all to see? Okay, there you go. So require is used to validate inputs and conditions before execution. Assert is used to check for code that should never be false. Failing assertion probably meant that there is a bug. Revert is something you want to abort execution and revert state changes, because we know that the way blockchain operates is that sometimes you have state data. You want to make sure that if there's any error, you don't want the state data to change. So you then revert the contract execution. So these are some of the differences between require, assert, and revert. So that's why you notice, right, in our contract, we have require, maybe we have require instances where, like here maybe we add something like require index is less than array dot length. Wait. And if this condition fails, array out of bounds. So we will try to run this in a while. Now we know that when we call this function, these are the two things that's happening, right? But we missed out one more thing. Now, array.pop means that you're removing the last element. So you're removing the element at index 3. So meaning, after you do this function, index 3 would not exist anymore. And then you're asserting that the array length should be 3 after you remove it. And then you're essentially ensuring that the array rearranges itself. You're making sure that all this is actually true. And then if you remove 2, right, it's the same thing that is going on here. So that's like the rough idea of what's happening when you try to call this function. Now let's say you want to call this remove function, right? So let's try to save this. Okay, there's an error here. What is the error? Expected is semicolon, but you got an identifier. Oops, sorry about that. Then you compile, you try to deploy it. Then here. So let's say if I try to remove, if I just say 2 first, wait. Okay. Is there an error that's telling me? Okay. Later on, we will explore how to get back the error message when we try to execute the contract, right? These are called events, if I'm not mistaken. So we will explore this later on. But for now, okay, what if I try to remove this, comment this, then deploy again? Oh man, all this. Okay. Okay, I just call first. Oh, nope. Photo. Okay. Right. Debug. So I give it a value of 2 just now. What if I try 0? I don't think it should give me an error lah. Okay, just give me an error. All right. We skip this for now. All right. Let's go to what's the other part? Enum. Okay, there's still enums. Wow. All right. It's going to go over to enums. So mapping array. Now we got enum. So enum. Let's say you want to you want to model your choices and keep track of state. Enums can be declared outside of a contract. So let's say you declare a contract enum, you want to declare like a shipping status, all is status, right? So default value is the first element listed in definition of the type. So in this case, pending. So status, public status. You're calling the enum, then you're defining the modifier here, and then this is your variable name lah, basically. Then it returns a U integer. So function get public view returns status. So you're returning the status here. Okay. Then so again you have your getter function, your set function, your cancel function, and your reset function. Let's try to import this to our code and see what it does. So you must use a number because see, I did a mistake here. You're actually requiring a number, right? So you're supposed to give like values from 0 to 4. If I give 2, smart. All right. Then you have 2 here. Forget on status. Okay. How about cancel? Cancel will just okay. Interesting. If I try get again, 4. What is 4? Oh, okay. So I think, right, what's going on here is that you have a local variable called status here, and then, right, you want to set. So let's say the initial state you want to set it as pending. So you give it a value of 0. Then you give set. Then you get the value is 0. 0 actually corresponds to pending. Then if you want to cancel, right, so cancel, it will go back to 4. So you might be wondering, how does it even get the numbers in the first place? It actually corresponds to the index value here. So 0, 1, 2, 3, 4. Then if you try to cancel it, you get status again. Should give you cancel. So that makes sense so far. That's enums. Then you have declaring and importing enum. There might be cases, right, you want to declare an enum in a separate file. So maybe you copy this, go here, you go to files, you add a new file, you call it enum declaration. Oops. Enum, wait, I'm just going to rename that. Enum declaration.soul. Then you go here, go to this file, copy, paste the enums here. Then you go to a separate file, the main file that you editing just now, you copy this, you paste it in the BYOS.soul. Bro, what? Not found. No, I just oh. Oh, can already. Okay. Can. Then you. I can't deploy. Where's my deploy? No. They don't compile contracts. Never mind, I go back here. Okay. That's weird. What's not found? Oh wow, I missed the T. Nice. Okay, it should work now. Okay, so that is a basic example of how you can declare enum in a separate file and import it in another file. Let's say you want to keep things more structured. Next, oh wait, what's the time now? something 145. Never mind lah. I think. Never mind. We still have what else we have? Okay, we have another one. Next one will be heavy. So let's just take a break till 2 o'clock for now, because I think everyone has been having issues with arrays, right? Let's take a look at arrays now. Yeah. Yes. Let me just put this first. Right. We are back online. I'm just gonna type this in. It's okay lah. For first workshop, it's got people online, bro. Right. We're gonna continue. So now we're gonna look into data locations. So just now, Kit Hang asked, what's the difference between memory and storage and call data? I mean, he just asked what's the purpose of memory, but now I'll explain further on that. So generally, when you do programming, of course you define your variables, right? And then like when you define your variables, you don't really need to worry about where the variables are stored. But in Solidity, sometimes you actually have to consider that. That's not sometimes, because you're actually dealing with like state variables. Then you're dealing with like the blockchain itself, right? So variables are declared as either storage, memory, or call data to explicitly specify the location of the data. So briefly, right, storage just means a variable that is a state variable that is stored on the blockchain. So generally, when you attend like any talks online or when people talk about their projects to you, sometimes they might go a bit technical. Then they might start talking about like state variables and things like that. When they mention about state variable, just one thing: variable that is stored on the blockchain. Then you have memory. Memory is a variable that is in memory and it exists while a function is being called. So one way to look at this is that there is the blockchain, and of course, in Ethereum, right, we have this thing called the Ethereum virtual machine. So the Ethereum virtual machines is where your smart contract gets executed. And in the context of the Ethereum virtual machine, when your contract gets executed, you're also dealing with memory, like how our computer has memory, RAM. Sometimes when you deal programming, definitely your code will need to access certain data on the RAM, right? The same concept applies to when you do your smart contract development. There will be memory involved. So there will be certain variables. Maybe you don't need these variables to be stored on the blockchain. So you use memory. And then you have call data. Call data are special data location that contains function arguments. This one is when you call the function, you give the parameter, sorry, not parameter, you give the argument. This is considered the call data. Now let's take a look at a code example here. So it's a regular thing. You're defining your license identifier, you're defining a compiler version, you're defining your contract name, and then you're defining a unsigned integer, you're defining an array that consists of unsigned integers called array, and then you're defining a mapping that consists of the key is unsigned integer, the value is address. It's called a map. Then you're defining a struct. Did we go through struct? Okay, we did not go through structs. Okay, never mind. We will go through that after this. So there is struct here. Struct is another data type after enum and also mapping and array. Then for this struct, right, you're also doing a mapping. So one thing to note here is that like mapping is a bit flexible in terms of how you do your key to value kind of pairing. So you can have integer to a struct pairing. Then you're defining a function f. It's public. You're calling f with state variables. So this is f. F is actually okay. You call f with state variables. So the function f, you pass it an array, you pass it a map, then you pass it the struct my struct. We are saying one here because I think okay. I'm not too sure about this yet. We will revisit. We will revisit this later. Then you will get a struct from a mapping. So you're defining a my struct, you're storing it in storage, then you're doing all this, right? Then you're also creating a struct in memory. Okay, so I think everything else what is showing here is how the variables are being stored. But before we proceed further, let's just take a look at structs first. I go to structs. Here you go. So you can define your own data, okay, not data type. You can define your own type by creating a struct. They are useful for grouping together related data. You can define a struct outside of a contract and you can import it in a contract, like how we imported our enums just now. So in this contract, you're defining a struct called to-do. And in the to-do is a kind of a struct where it's a to-do list. And in the to-do list, you want to just have, you want to store a text and you want to store a Boolean value to see whether it's completed or not. So you have an array of to-do struct. You're defining an array called to-do. Then this one, right, is basically here. So you call it here. You give the square bracket here. You say it's public, and then you give it a variable name called todos. Then you have function create. Here, you are passing it just one thing, which is the, okay, so here you notice it's call data, right? This is where, remember what we mentioned just now about function arguments? So here you're passing, since you're passing the text as call data, it means that you're passing this as an argument. So it makes sense to define storage type call data. Then it's public. So there are three ways to initialize a struct. You can call it like a function. Todos, so todos because you already declared it here. So you're pushing another struct. So todos.push to do, and then these two are, okay, text and false, right, corresponds to text and completed. False is false because it's a Boolean value here. So then it's a key value mapping. Todos.push to do. Then yeah, this is another way of doing it. Key value mapping is one, calling it like a function is another. So you can slightly see the difference here. Then you can initialize an empty struct and then update it. So to do memory to do, then to do.text is this one, and then you're pushing this value, right? It's actually this value, right? Then solidity, right? It automatically creates a getter for to-dos. So you don't actually need this function. So this part, right? You don't really need to create it, because apparently here it mentions that it will automatically create a getter function for to-dos. But of course, you can create your own function to update the text inside. So what you can do is you're giving it an index number, you're giving it the call data. Now here's an interesting question. You might be wondering why, like, this one needs call data, this one does not need call data. All right. So what we can try is again, if you guessed it, I want to just copy this entire thing. I'm going to actually want to ask ChatGPT also again. So let's just see. I'm just kind of curious what it comes up with. So what I'm going to ask is, for the function update text, okay. So there you have it. Oh, they're still typing. Okay. It's so long, man. Yeah. Okay. So here, we know that the text parameter is a string, which is a dynamically sized data type, where the index parameter is an unsigned integer, which is a statically sized data type. So of course, in Solidity, there are two types of data storage, memory and storage. Call data is a special type of memory that is used to store function arguments that are passed from outside the contract. And it's cheaper to access than regular memory. So when a function is called from outside the contract, its arguments are copied to call data, which is read-only and cannot be modified. So the index parameter here is used to access an element of the to-dos array, which is stored in the contract's storage. Unlike call data, storage is a persistent storage area that can be read from and written to. And it's more expensive to access the call data. Okay, so here it's mentioning that, so if you wanted to know why text has call data and index doesn't have call data, right? So according to ChatGPT, it says that since text is a dynamically sized data type that is passed from outside the contract, it's more efficient to store it in call data. The index parameter, on the other hand, is statically sized that is used to access the contract storage. So it does not need to be marked with call data. So essentially what he's saying here is that for dynamically sized data type, it makes sense to store it in call data because it is more efficient in that sense. So that's something to take note of. Generally, when you have dynamically sized data types, you want to store it, you want to be able to store it, right? You can actually consider using call data. So you might have, now, dynamically sized data type, I think there is a string, there is, not sure about others like struct and things like that lah, but we can definitely do more research on that. Then we have what else? Okay, these are some of the other functions: update text and toggle completed. Yeah, declaring and importing struct, it's the same thing here. Okay, so we briefly went through we briefly went through like the how structs work, right? So one thing I want you guys to take note of is how we can declare it, how we can access the data inside the struct. It's a bit similar to mapping, but it's different in the sense that struct, you're actually defining beforehand how you want your data to be declared in a particular order, or rather how you want to group this data. So if you want to create a to-do list, then you want your text and also you want the completion status. Okay, enough about struct. Let's take a look at data location. So just now we stopped at we were looking into how they define all these different uh, data types, right? So I think we stopped at here. Okay, now we have so I think the key takeaway from this is that to understand when to use storage, when to use memory, when to use call data. So what we can try is later on we will have a clearer picture of when to use which type of data location when we're doing that mini project. Okay, I'm just gonna close this. What else? Okay, let's now take a look at function. Function, we have a function. Okay, right. Function, I think we've already been exposed slightly to function. Let's take a better look at it. Right. So there are several ways to return outputs from a function. Public function cannot accept certain data types as input or output. Okay, let's see what that means. You have a contract function. So this is a function that can return, okay, it's a function that can return multiple values. So you have function return many, public pure returns. So if you notice earlier, we only defined one, right? But you can actually do more. UINT, bool, UINT. So you're returning values like this. And then you can also name the return values. So let's say, right, you want to, instead of doing it like this, you want to do it like this. You can also do it like that. So let's say you want to call this number 1, status, then number 2. You can even do that. Then return values can be assigned to their name. In this case, the return statement can be omitted. So let's say you want to do something like this. You want to skip the return value, return keyword entirely. So what you do is, you have the returns keyword here already, right? Then you declare all this already. Then you're just, the values are already here. You're already like, you're assigning the values. So this function would just be written lah, assigned. So let's say, right, I'm going to try to straight copy this also. I paste it later on. Let's take a look at the others first. Okay, destructuring assignments. So function destructuring assignment, public pure returns all this. Then, okay, d equals return many. Where is return many? Okay, here. Now, imagine, right, you call a function and you want to, the values you get, you want to straight assign it to the variable that you declare. So here you're calling return many, and return many would give you these 3 different variables. So these 3 different variables will be assigned to I, B, and J. Then, let's say it says here values can be left out. So you only want to assign values 4 and 6 to X and Y, but you don't want to assign 5 to anything. You can just put a comma, space, comma. You can just omit the variable. You can do that. So this is a simple example of how you can destructure the return value, or you want to just, maybe you have a value, you want to assign it to certain variables, then you skip certain values lah. So in this case, this one. Then, so here it says you cannot use map for either input or output. Cannot use map for either input or output. Okay, I need to see later on what that means. Can use array for input. So you have function array input, then you're defining a variable here in memory. And then you can also use array for output, like this. So these are the 2 different ways of how you can declare the array for input and also output. Same thing here. What else? Yeah, this is actually a bit difficult to understand at first, but once you get the hang of it, then we try to implement it and see if you can understand it even further or not. So this is another contract XYZ function, some function with many input. So these are all the parameters you're expecting, and then it's returning an integer. So function call function. You're defining the function here, then you're returning this function, which is this function. You're giving it all the variables, 1, 2, 3, address 0. Can anyone tell me what address 0 means? Any guess? Address 0. No idea? Okay, no idea. Address 0. Any, yeah? So address 0 is like null address. So let's say, right, I go here, search. Okay, I will. So you see, address 0, all 0 here. Yes. So yeah, that is one. Then we, yeah. So this is some examples of how you can call function with key value inputs. I think that example is actually here lah. Call function with key value. So you're calling this function some function with many inputs. Let's say, right? Okay. Okay, let's see how this works here. Now, sometimes it might be the case where you declare it in this order. You might be wondering, hey, when I want to call this function, I need to pass these arguments in a certain order. But that does not need to be the case. What you can do is, you can call this function, you surround these parameters like these curly braces around it, you give it the key value here. Then when you call the function, it will automatically be assigned. So let's say A here, it will be directed to address here. And then you have B here, true, it will be passed to this one here. So that's how we can automatically assign one by one, okay? So I think, all good so far? Guys over there, all good? All good? All good. Here? Okay. Next, view and pure function. Okay, before we proceed further, you want to take another break or what? Okay, proceed. Proceed first lah. Proceed lah. Proceed, okay. Okay, now we have view and pure functions. So view and pure functions. One moment. Okay. Okay, so you have getter functions that can be declared view or pure. View functions declares that no state will be changed, like what Vincent mentioned just now. I think we'll take a look again later. So if you declare a function as view, it means that that function cannot modify any state in the blockchain. But if let's say you have pure function declares that no state variable will be changed or read. So it's two different things. View means no state will be changed. Pure means no state variables will be changed or read. Let's try to look at code examples to understand how that works. So contract view and pure. You're defining a unsigned integer x1. Here in this function, you see public, the difference is public view and public pure here. Then function add to x. So you give an unsigned integer y, and like public view returns you integer, right? So return x plus y here. I think I can't really demo here like this, so I'm going to just copy this and also paste in Remix. Okay, compile this, delete all this, deploy it. Okay, currently the value of x is 1. If I add to x here, 2, if I try to x again, okay, add to x, because it's public view, it can't modify the state, right? If I try to add 2 here, another one, see, 1, 2. Oh. Okay. So try it again. I was getting 3 here. Okay, let's try to explore this again, yeah? I'll try to remove all this. Okay. Now we will try to figure out what does add to x do. Now add to x is defined as a public view, which means that it promises not to modify the state. Ideally, we have this is a local, sorry, this is not local, this is a state variable. So just now we mentioned about 3 types of variables, right? Local, state, global. Global just means that you're taking data from a variable which gets data from the blockchain itself. In this case, this variable, you're defining it under the contract itself. You're not defining it under any function. So it's considered a state variable. So let's say if I use the add to x function, if I give a value of 2, okay, it does not return anything. Let's see what's the decoded output. Okay, so it means that you're not manipulating the value of x. X still remains 1 because after you add to x 2, you're just returning the value, the result. You're not manipulating the value of x and then returning the result. So let's say, so same, right? Even if I give 4, I still get 5 here. But then x still remains the same. What if I do like function add? So this one promises not to modify or read from the state. So it just means that there is no x involved here. But I'm kind of curious, what if I put this as pure? Let's see what that does. Okay, there's a problem here. What's the problem? Function declared as pure, but this expression potentially reads from the environment or state and thus requires view. Now you see, it actually debugs for you and tells you the error there itself. But yeah, so that is the difference between view and pure functions. So this one, maybe there are instances where you want to make sure that the function does not modify the state variable or it does not modify or read from the state, right? That's what I can do. So if I remove view here, ideally it won't compile. Like that. Oh, it compiles. But it gives a warning saying that it can be restricted to view. What if I try to deploy this? Oops, sorry about that. Interesting. So if I do like this, it does not give me the return value output here. Oh, okay, it does. That's 4 here. Then what is the value of x then? Okay, still maintain the same lah, still 1. So which means that it does not get modified lah. Okay, that is the difference between view and pure function. Next, let's take a look at error. So an error will undo all changes made to the state during a transaction. You can throw an error by calling require, revert, or assert. Assert we already went through just now. Let's take a look at require. Oh, sorry, require also we went through just now already. So here is a very brief explanation. What is the difference between require, revert, or assert? So require you use when you want to validate inputs and conditions before execution. Revert is similar to require. Okay, let's see what's the difference down below first. Okay, test require. UINTI, public pure. So pure again, it means that you're not modifying or reading from the state. So it requires that this I is more than 10 and input must be greater than 10. If it's test revert, revert is useful when the condition to check is complex. This code does the exact same thing as the example above. Okay. So this is a simple example. If I is less than or equals to 10, you revert with input must be greater than 10. So this is in cases where you want to check conditions that are a bit complex, so you use revert. Okay, that's require and revert for you. Then, oops, sorry. Now you have an unsigned integer num. You want to test assert. Okay, we didn't go through what assert means. So assert is used to check for code that should never be false. Failing assertion probably means that there is a bug. So that's how you can adjust your code lah. So you go here, test assert. You assert that num. Okay, assert should only be used to test for internal errors. So that's how you look at it. Assert for internal errors, require and revert for external errors. So this require and revert, right? Since you're checking for the user input, you use it for external errors, and then assert is for internal errors when you want to check internally within your code. Want to prevent any bugs from happening, that kind of thing. Then, okay. So here, we are essentially asserting that the value of num is always equal to 0 because it is impossible to update the value of num. That's how you can do it, lah. Insufficient balance. Okay. Here, we mentioned one more thing. You can use custom error to save guess. So we go here, right? You're defining a custom error here. Error insufficient balance. But where are we calling this insufficient balance? So here's a balance, and then like there's a withdraw amount here, right? Then your function test custom error. You're giving it a value called withdraw amount. Then unsigned integer balance equals. So address of this, right? Remember, initially when we talked about the data type address, we compared it with the public address of the MetaMask. So here we are wrapping the this address around the data type address lah. So this, right, will correspond to the address of whoever called the function. Okay. So you assign a balance into this unsigned integer balance, and then if balance is less than withdraw amount, you revert with this error called insufficient balance. But this is another example here. See. Oh, okay. This is a more practical example lah, easier for you guys to imagine. Okay, let me see what else I haven't covered first. Oh, okay, we got two more. So this is another example of a contract. You are defining public balance, state variable, max UINT, state variable, function deposit. So you're defining a function called deposit. You're giving it a value amount, and then there's an unsigned integer old balance equals balance. Now this one, right? You do it when this happens when I think it's a left to right assignment. So it means that if I'm not mistaken, the value of old balance, you're giving it to balance. I might need to double check that. Wait. Okay, it assigns the value of balance variable to a new variable called old balance. So old balance will get the value of balance. So I think so it's not left to right assignment, it's a right to left assignment. Yeah, it's right to left. Basically the value of balance, you'll be giving it to old balance lah. That's what it means here. Then everything else, I think everything else here is pretty much quite straightforward. What else? Yeah, we went through require, we went through this balance, we went through assert. Yeah, so these are some examples. I think you guys also check it out lah later on in this example. Then we have function modifier. Okay, function modifier. Modifiers are code that can be run before or after a function call. So we can use modifier to restrict access, validate input. Okay. Remember earlier we talked about re-entrancy hack. So this is where we would start looking into how to prevent that. So you have a contract function modifier. We will use these variables to demonstrate how to use modifiers. So you're calling all this, you're defining all these variables. So constructor, right? Basically, constructor works because, okay, how it works is that, let's say when you first deploy a contract, yeah, if I'm not mistaken, when you first deploy a contract, it will set the value of owner to message to sender. So whoever who deployed the contract, the state variable here will be assigned, like owner will be assigned the value of message to sender lah. Then modifier to check the caller is the owner of the contract. So you see here you want to create a, remember we talked about access control earlier, right? So you want to make sure that only the owner is able to, let's say in some instances, only the owner is able to call a certain function. So you first define that condition called only owner, and then here you define a require condition. You require that the message to sender is actually the owner, and the owner is actually up here. If it's not the owner, then you give this error. So underscore, right, is a special character only used inside a function modifier, and it tells Solidity to execute the rest of the code. That's why you do this. This is only for modifier. Modifier can take inputs. This modifier checks that the address passed is not the zero address. So the same thing, we talked about zero addresses now. Okay, now how do you use this modifier? How do you call the modifier? You declare a function, and then you just have to add only owner and valid address here. You see, you declare here, you call it here. That's all. And that's how you're able to check in one go. Okay, let's say you want a function change owner, right? But you want to check certain condition. You want to know that the person who called the contract is a valid owner. You want to know that the address given is a valid address, not a null address. So you define these two things. Of course, with valid address, you need to pass it argument lah, new owner. So yeah, this is a very basic example, but it really helps with how you declare certain special use cases you want to guard against. Now, welcome to no reentrancy. So modifiers can be called before and after a function, right? So this modifier prevents a function from being called while it is still executing. You execute a function and then you want to execute again. That second execution will be blocked because you want to finish the current execution first. So here, right, you have a modifier no reentrancy. So it requires that currently the value of locked is not true, if I'm not mistaken. So ideally, if you want to prevent a contract from being re-executed, the current value has to be false. The current locked value has to be false. So if the locked is true, then it will return like false. That's what it means here. So you have a function decrement, right? Decrement, you import a modifier called no reentrancy. So x minus equals 1. So this one you're reducing the value of x by 1. If I is more than 1, so if you're passing the argument here, I is more than 1, then you decrement the value of I by 1 here, which is this one lah. This one, feel free to test it out in the IDE later on. So we already went through briefly on modifiers. So I think last we can have, what's the last one? Events. Okay, right. So this is the last basic lesson of the day, events. And after this, we'll have a short break, and then you guys can start working on like implementing your own project already. I'll brief you all shortly on implementing that. Okay, events. So events, they allow logging to the Ethereum blockchain. This is important. You execute a contract. You want to know what's going on in your contract. How do you get the data? Because it's a blockchain, then you want to get the data back, right? You use event for that. So some use cases for events are, you want to listen for events and update your user interface accordingly. And it's a cheap form of storage. So contract event. So your event declaration here, up to 3 parameters can be indexed. You might be wondering what are index parameters for? Well, index parameters helps you filter the logs by the index parameter. So basically, this is a way for you to efficiently filter the events. So I'll do the same thing like what I did to ask this last question. Over here, let's take a deep look at why we use oops. Because I need to buy ChatGPT Premium. you belanja me lah. So according to ChatGPT, the index keyword is used to mark certain function parameters of the event as index. Yep, like what I said earlier, it allows for more efficient filtering of events. So let's say you provided log event has an index parameter sender, which means that it can be used to filter for events emitted by a specific sender address. If you want to search for all events emitted by a specific sender, you can use the from filter when querying the event log, which will then use the event index to quickly find the relevant events. Long story short, you want to efficiently search for data, right? Like when you want to get an event, you want to know for this event by this particular address how to quickly get the data back. You use index keyword here. But one thing to note is that only a maximum of 3 parameters can be indexed. So be careful with how you use it. Maybe not all parameters you want to index it. So here we only index the sender, but not the message. So you declare an event here, then you declare another event here. You call a function test, and then along coding it, right? Maybe you want to emit a log. Upon a certain function being successfully executed, you want to emit like, okay, this function has been successfully executed, things like that, right? Then maybe you can use emit for that. So let's try to copy this code and let's figure out how emit works in a real world use case. So I go here, then I compile. You see all this? Hello world, hello EVM, another log. All these are under event. So that's how you're able to trace the data back. This is another way lah. Of course, it's not showing here, but I think that's because we're not returning. That's not because we're not returning the value, so it won't be shown here. But since we declare emit log, right, it will be shown in like the return value lah. So you can actually see under logs. So this is something to definitely explore further. Something more interesting. But yes, that sums it up for now. Very basics. I know it has been a lot, so we can definitely explore this more when we're doing the side project later on. So for now, I think it's 2:40 now. Okay, let's have 20 minutes break until 3 o'clock, and then we can get started on doing our own projects lah. I'll share that later on. But yeah, let's take 20 questions. Anyone? I'm just gonna walk around. Get questions. Yeah. So good. I think the demo project we have a chance to explore. I'll also like to do it. I so when papers sometimes really notice my so basically I'm debugging tiny and you want to see then I want to have all these smart contracts. So we don't take this in fact we try to be running it. Okay, we're back. So now we're gonna start building the project. I'm just gonna go back to the screen. Yep. So we'll be working with this project. It's one of the projects that's under the repository that you guys clone when preparing for the workshop. This is called a token vendor. So we're going to do a simple smart contract implementation where we're able to like create like a smart contract that's able to buy and sell currency. Again, it's not mainnet, it's on testnet. We're not going to use real money. So we will learn about how okay, so there's this thing called ERC20. So I just say very briefly what's the difference between ERC20, ERC721, and ERC1155. Who here are familiar with NFTs? Please raise your hand. NFTs, anyone? Okay, there's one here, there's two here, there's three, four. Anyone else? You all know what NFT is? Okay. Okay. Yay! Okay. Not sure. Okay, so we have ERC721 is like NFTs, right? ERC20 is more specific for cryptocurrencies. So think of it like this. It's basically like different ways of how you implement your smart contract. Then we have ERC1155. Now ERC1155, it can be fungible or non-fungible token. So ERC20 is like fungible token lah in a way. Now what we're going to do is we will do a deep dive into how we can this thing called approved pattern for ERC20 and how contract to contract interactions work. So oops, sorry, I was like okay. Right. So now what you can do is go to the GitHub repo. I'm just gonna bring that screen up. One moment. One moment. A. Thing L. Okay. All right. See if I can bring the screen here or not. Okay. Okay. So I'll go through briefly on what we're going to do today. I did explain about this part. So we're going to create so you can just rename this thing lah, your token also. You can just even put your name if you want to. We're going to create a Solidity file, smart contract that inherits the ERC20 token standard from Open Zeppelin. Okay, set your token mint to 1000, the message sender, and then create a vendor.sol contract, exercise the token using a variable. So we're going to have two Solidity files. One is your token.sol, another one is vendor.sol. Then after we create the smart contracts, we're going to edit the front end that invites the user to input an amount of token they want to buy. we will display a preview of the amount of ETH or USD it will cost with a confirm button. It will be important to verify your token source code in the Block Explorer after you deploy. Supporters who want to be sure it has a fixed supply, you can't just mint more. We will take a look into Block Explorer. So this one, I showed one briefly just now, Etherscan. Hold on. Yeah, I showed Etherscan. Etherscan is one example of a Block Explorer. There's also Polygon Scan. There is also Aurora Scan, if I'm not mistaken. Then there's like a lot of other Block Explorers now, basically. So there'll be like different Block Explorers for different chains. But for now, we are just concerned for Ethereum. We're just going to build on Ethereum first. So after we do all this, so the final deliverable, ideally, right, at the end of this workshop, we want to work towards an application that lets users purchase your token, transfer it, and sell it back. Maybe we will not be able to implement everything with the time constraint that we have, but we try to do the best that we can. So after that, you'll deploy your contracts on your public chain of choice, and then use these commands to serve your app like a public server. So let's get started. Okay. First things first. Since you already cloned the repo, so you can just open up any of your IDE. I'm just going to open up my Visual Studio Code. Bring it up here. I hate this. Okay. Control O. Okay, file. Let's see. Documents. Where did I save it? Oh, here. That's weird. I hope I get cloned though. Right here. documents. Oh well, never mind. I can always reclone it again. Huh? Yeah. The right side is terminal, then left side is the IDE lah. Yeah. I'm just gonna clone the repo again. So wait, hey, is bro, I hate having it on two screens lah. Seriously. Okay. Oh, okay. What? Then do I have to clone another one again later on? Oh, okay. Just gonna go back here. CD challenge 2 git checkout. Okay. So after you clone the repository, right, you would have to okay, I'm just gonna clear this string first. Git checkout, git checkout to the name of the challenge, which is, let me see, what is it? Challenge -2 -token -vendor. Okay. Hey. So after you already check out, you run yarn install. Yeah. Git checkout to the name of the challenge. GM, Mr. President.